This video is just going to be an introduction to the graphs of the inverse trig functions. Although we're not going to really be doing much with the graphing part, we want to look at what the graph means about finding the inverse values. So the first one we're going to look at is inverse sine. And what I want to look at is, it doesn't look like a sine graph currently, but if I were to continue, and the inverse obviously is going to be reflected over the line y equals x. So here is your original sine graph. In fact, I didn't really do an amazing job there, so let me just fix this first part. Now, if we do the inverse, and we're reflecting over that line y equals x, the graph itself would continue this way. So the inverse graph would keep going, and then same thing this way. This is going to be true for all the other functions as well, so we will look at that. Now here is the problem. If I now go and do a vertical line test, it fails miserably. It's going to hit an infinite number of times, because remember, the sine function is continuous. It's cyclic, or it's periodic, so it keeps on going. It looks the same over and over again. So what we're doing here is we're restricting down. We're getting the closest part of the graph to the x and the y axis. So we're getting rid of what makes it not a function. Okay, so right here, if I were to keep going, no longer a function. Same thing here, if I were to keep going, no longer a function. So our domain for this graph is going to be -1 to +1. That's important when we're picking values later on, or we're doing inverse values. Anything outside of that domain won't work. If we try to do inverse sine of 1.5, not going to work. So that would be something that doesn't exist. There wouldn't be a solution to that situation. The range, now it shows -1.5 to 1.5 about, it's really -π/2 to π/2. So our range here is -90 to 90, or -π/2 to π/2. Now this is an important set of values, because this range tells us what our principal values are. And if you look back up to the top, a principal value is a value where the inverse graph is a function. Star this, whether or not it's going to be on the quiz or the test, I do ask you to define what a principal value is again, so make sure, just like you've done in previous studying for quizzes and tests, to review your notes for those key pieces. So the values that make this graph a function are the -90 to 90 and the -π/2 to π/2. Now we did a little bit of inverse work in the first unit, so when we get into doing the inverse notes next, you will see that the values we're going to get, instead of 0 to 360, which we had talked about in the first unit, we want to pick values within the principal value range. So for example, if I want to do inverse sine of -1/2, now it's time to break out that unit circle again, because we have to remember these different values. So reference angle for that would be 30. Now technically it's negative in a couple quadrants, third and fourth, but we're looking at it being negative in the fourth, and it's only going to come out to -30. And if you were to plug that in the calculator, that would be the answer the calculator would give you in degrees. So -30 or -π/6 if we are looking to do it in radian measure. That's a little different, because before we did look at 0 to 360. So we want our values to be in this range. So you can figure out what it is in the fourth quadrant, but then subtract your 360 to get that coterminal angle, so it is in that range. And then inverse sine of √3/2 is going to just be the positive first quadrant. So anytime it's positive, you're always working with the first quadrant angle. So that's easy. It's the negative ones that are going to be tricky for our different functions. All right, we're going to look at the cosine function also right now. And then tangent and cotangent are slightly different, so we are going to look at those separately. Those we don't do inverse cosecant or inverse secant because we can use sine and cosine for solving for those. What's up? So it does say that down here, like I just mentioned, inverse cosecant has the same principal values as the inverse sine function. And then same thing, inverse secant has the same principal values as inverse cosine. So we don't need to do a separate graph for those. And then for the same reason for our cosine graph, if we were to continue, now we're picking the one that's going to be closest to the positive x and y axis. So this piece is a little bit weirder of a choice. You'll notice everything is in the positive zone. The second I continue on that graph, it is no longer a function, right? It fails that vertical line test. So we want to get rid of that information. Now this one's different. Our domain here still is -1 to 1, like before. So that was the previous range of the cosine function. But the range is going to be 0 to 180 or 0 to pi. Not degrees. Okay, so that's going to be a little different and a little weirder because we're going to be picking values from quadrant 1 or quadrant 2. So it's really going to be important to know your reference angles here. If we're doing inverse cosine of -√2/2, our reference angle is 45 for that, or pi/4. So rather than putting -45, we're going to get the angle in the second quadrant, which would be 180 minus 1 or minus 45. So that would be 135, or in radians, 3 pi/4. And then similar to before, if we're doing inverse cosine of something that's positive, it's still going to be in the first quadrant. So this one would be 30 degrees or pi/6. So you will see how it's important, again, to break back out that unit circle. Because that's really going to help you with the part that will be tested no calculator. All right, so I'm going to do a second video just for the other two. Make sure that you fill in everything on here. Again, make those notes for going back to review for studying. Here, we're mainly going to use information again for the next lesson, which will be where we're actually going to do the math value. This is really just your introduction to it.